The 2002 National Electrical Code, specifically Section 517.33, did not contain explicit mandates concerning critical branch circuits within hemodialysis centers that operate on an outpatient basis. However, a significant revision occurred with the introduction of the 2005 National Electrical Code. In the 2005 edition, Section 517.33 was amended to explicitly mandate the inclusion of critical branch circuits in hemodialysis centers providing outpatient services. This pivotal requirement established in the 2005 National Electrical Code has been consistently upheld and reinforced in all subsequent editions of the National Electrical Code. Examining the current National Electrical Code, Section 517.33 explicitly states that, in addition to the requirements outlined in 517.32, each hemodialysis center operating on an outpatient basis must be equipped with a critical branch circuit configuration. This critical branch must adhere to the specifications detailed in Sections 517.33 through 517.33c. The role of critical branch circuits is to ensure a continuous and reliable power supply to essential equipment and systems, particularly those vital for patient care and safety during power outages or disruptions. Within a hemodialysis center, these critical systems encompass the dialysis machines themselves, lighting in treatment areas, and life support equipment. Given the potentially life-threatening consequences of power interruptions during dialysis procedures, the consistent and uninterrupted operation of these systems is of paramount importance. The precise reasons behind the Texas Department of Health's assertion that critical branch circuits are not mandatory in hemodialysis centers remain unclear. This stance directly contradicts the unequivocal and unambiguous requirement stipulated by the National Electrical Code. It is imperative to recognize that the National Electrical Code serves as the authoritative standard for electrical installations and safety. Its provisions are meticulously developed and regularly updated to reflect the latest advancements in electrical technology and best practices in safety. The National Electrical Code undergoes a rigorous consensus-based revision process, ensuring that it represents the collective expertise of electrical engineers, contractors, inspectors, and other stakeholders involved in the electrical industry. Any deviation from the National Electrical Code requirements can potentially compromise the safety of patients and healthcare professionals within hemodialysis centers. In conclusion, it is unequivocally clear that the National Electrical Code mandates the presence of critical branch circuits in hemodialysis centers that provide outpatient care. The interpretation put forth by the Texas Department of Health stands in direct opposition to these clearly defined requirements and should not be regarded as an accurate or reliable source of information. It is of utmost importance to adhere to the National Electrical Code's guidelines to ensure the safety and well-being of all individuals involved in hemodialysis procedures. The specific requirements for critical branch circuits as outlined in 517.33 through 517.33c detail the essential components and performance characteristics of these circuits. Section 517.33 typically addresses the essential electrical systems that must be connected to the critical branch, including but not limited to dialysis machines, essential lighting, and alarm systems. Section 517.33b usually specifies the permissible sources of power for the critical branch, often requiring connection to an emergency power system such as a generator or an uninterruptible power supply, known as a UPS. Section 517.33c commonly outlines the testing and maintenance requirements for the critical branch, ensuring its reliability and functionality during power outages. To ensure full compliance with the National Electrical Code, a thorough understanding of these specific requirements is crucial. Consulting with qualified electrical engineers and inspectors can provide valuable guidance in the design, installation, and maintenance of critical branch circuits in hemodialysis centers. Furthermore, regular inspections and testing of these circuits are essential to identify and address any potential issues or deficiencies that may arise over time. These inspections should include verification of proper wiring connections, testing of emergency power systems, and confirmation of the functionality of all connected equipment. By adhering to the National Electrical Code's requirements and implementing a comprehensive maintenance program, hemodialysis centers can ensure the continuous and reliable operation of critical electrical systems, safeguarding the health and safety of patients and staff. It is important to note that the National Electrical Code is not a static document. It is revised and updated every 3 years to incorporate new technologies, address emerging safety concerns, and improve the overall clarity and usability of the code. Therefore, it is essential for electrical professionals to stay current with the latest edition of the National Electrical Code and any applicable local amendments or regulations. This ongoing education and training ensures that they are equipped with the knowledge and skills necessary to design, install, and maintain electrical systems that meet the highest standards of safety and performance. The Texas Department of Health's interpretation may be based on outdated information or a misunderstanding of the National Electrical Code's requirements. It is recommended to engage in a dialogue with the Texas Department of Health to clarify the basis of their interpretation and to provide them with accurate information regarding the National Electrical Code's mandates. Collaboration between healthcare providers, electrical professionals, and regulatory agencies is crucial to ensure consistent application of the National Electrical Code and to promote a safe and reliable electrical environment in hemodialysis centers. In addition to the technical aspects of critical branch circuits, it is also important to consider the human element. Electrical professionals working in hemodialysis centers must be properly trained and qualified to perform their duty safely and effectively. They should be knowledgeable about the specific electrical systems and equipment used in these facilities and be able to identify and address potential hazards. Regular safety training and continuing education are essential to maintain their competency and to prevent electrical accidents. Furthermore, communication and coordination between electrical professionals, healthcare staff, and facility management are critical to ensure that electrical work is performed safely and efficiently. Clear protocol should be established for reporting electrical problems, scheduling maintenance, and responding to emergencies. By fostering a culture of safety and collaboration, hemodialysis centers can minimize the risk of electrical incidents and protect the well-being of everyone in the facility. The design and installation of critical branch circuits should also take into account the specific needs and requirements of the hemodialysis center. Factors such as the number of dialysis machines, the size of the treatment area, and the availability of emergency power sources should be considered. A detailed electrical plan should be developed that outlines the layout of the circuits, the types of equipment to be connected, and the location of all electrical panels and outlets. This plan should be reviewed and approved by a qualified electrical engineer and should be readily available for reference by electrical professionals and facility staff. The selection of electrical equipment and materials for critical branch circuits should be based on quality, reliability, and compliance with applicable standards. Only approved and listed products should be used, and they should be installed in accordance with the manufacturer's instructions. Proper grounding and bonding techniques should be employed to minimize the risk of electrical shock and to ensure the proper operation of electrical equipment. Regular inspections and testing of electrical equipment and materials are essential to identify and address any potential defects or deterioration. The use of surge protection devices on critical branch circuits can help to protect sensitive electronic equipment from damage caused by voltage spikes or surges. These devices should be installed at the service entrance and at individual equipment locations to provide comprehensive protection. Surge protection devices should be regularly inspected and tested to ensure their proper operation. The location of electrical panels and outlets should be carefully considered to ensure easy access for maintenance and repair. Electrical panels should be clearly labeled and should be located in a well-lit and ventilated area. Outlets should be installed at convenient locations and should be protected from physical damage. Regular cleaning and maintenance of electrical panels and outlets are essential to prevent the accumulation of dust and debris, which can pose a fire hazard. The use of appropriate personal protective equipment, or PPE, is essential for electrical professionals working on critical branch circuits. This equipment may include safety glasses, gloves, insulated tools, and arc flash suits. PPE should be properly maintained and inspected regularly to ensure its effectiveness. Electrical professionals should be trained on the proper use of PPE and should be required to wear it whenever working on electrical equipment. In addition to the technical requirements of the National Electrical Code, it is also important to consider the ethical responsibilities of electrical professionals. Electrical professionals have a duty to protect the health, safety, and welfare of the public. They should act with integrity and honesty in all their dealings and should avoid any conflicts of interest. Electrical professionals should be knowledgeable about the National Electrical Code and should adhere to its requirements. They should also be willing to report any violations of the National Electrical Code that they observe. By upholding these ethical standards, electrical professionals can contribute to a safe and reliable electrical environment in hemodialysis centers. The specific requirements for critical branch circuits may vary depending on the local jurisdiction. It is important to consult with local electrical inspectors and authorities to ensure compliance with all applicable codes and regulations. Local amendments to the National Electrical Code may include additional requirements or restrictions that must be followed. Failure to comply with local codes and regulations can result in fines, penalties, and even legal action. The design and installation of critical branch circuits should be documented in detail. This documentation should include electrical plans, specifications, and test reports. The documentation should be kept on file and should be readily available for review by electrical inspectors and authorities. Proper documentation can help to demonstrate compliance with the National Electrical Code and can be valuable in resolving any disputes or issues that may arise. The National Electrical Code is a complex and comprehensive document. It is essential for electrical professionals to have a thorough understanding of the National Electrical Code and its requirements. This understanding can be gained through formal education, on-the-job training, and continuing education courses. Electrical professionals should also stay up to date on the latest revisions and amendments to the National Electrical Code. By investing in their education and training, electrical professionals can ensure that they are equipped with the knowledge and skills necessary to design, install, and maintain safe and reliable electrical systems in hemodialysis centers. It is also worth mentioning the role of the authority having jurisdiction, also known as the AHJ. The authority having jurisdiction is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, and installation, or a procedure. The authority having jurisdiction may be a federal, state, local, or other regional department or individual such as a fire marshal, building official, electrical inspector, or others having statutory authority. It is crucial to identify and work closely with the authority having jurisdiction to ensure that all electrical installations meet the required standards and regulations. The authority having jurisdiction can provide guidance and clarification on the interpretation and application of the National Electrical Code, and they can also conduct inspections to verify compliance. In summary, ensuring compliance with the National Electrical Code's requirements for critical branch circuits in hemodialysis centers is of paramount importance for the safety and well-being of patients and staff. It requires a thorough understanding of the National Electrical Code, collaboration with qualified electrical professionals, and adherence to local codes and regulations. By following these guidelines, hemodialysis centers can create a safe and reliable electrical environment that supports the delivery of high-quality healthcare services. Finally, it's important to remember that electrical safety is everyone's responsibility. Healthcare staff, facility management, and patients should all be aware of the potential hazards associated with electricity and should take steps to prevent electrical accidents. Regular safety training, clear communication, and a proactive approach to maintenance can help to create a culture of safety in hemodialysis centers and to minimize the risk of electrical incidents.